right, welcome to the Explainer. This is where we take really complex stuff and just break it down. Today, we're going to crack open the modern smart factory. And we're going to do it by looking at the one blueprint that really makes it all tick, ISA 95.
Okay, so let's kick things off with a problem that I'm sure a lot of you have felt. An order gets placed in the system, and then what? For so many businesses, the factory floor is just a total black box. The order goes in, and poof, it vanishes. So what is actually happening down there?
This black box, it creates all sorts of headaches, right? Production gets delayed, customers get antsy, and believe it or not, the root of the problem, the thing that starts this whole mess, is usually just a single piece of paper.
So let's make this real. Picture this. Your company's main business system, the ERP, it gets a massive order. Let's say for 500,000 computer mice. That's a lot of mice. The order's in, great. Now the real work is supposed to start.
But here's the catch. If you don't have a truly integrated system, that beautiful digital order just gets printed out. Yep, it becomes a physical piece of paper that someone literally has to walk down to the factory floor. And from that point on, everything, every single step, every little bit of progress is tracked by hand, if it even gets tracked at all.
So what happens when that customer, the one waiting on 500,000 mice, calls up and says, "Hey, where's my stuff?" Well, someone in sales has to play detective, right? They've got to hunt for that one piece of paper somewhere on a huge, chaotic factory floor. The most honest answer they can give is usually, I have no idea. I'll call you back.
And this nightmare scenario is exactly what the ISA 95 standard was built to fix. You can think of it like a universal blueprint, a standard way to finally connect the business folks in the front office with what's actually happening on the factory floor. So what ISA 95 does is it breaks everything down into 5 clear layers. Right at the top, that's level 4. That's your business stuff, the ERP. Then you go down to level 3, which is all about managing the manufacturing operations. Below that, you've got levels 2 and 1, which control and sense the machines. And finally, level 0 is the actual physical hardware, the motors, the sensors, the stuff that's actually making things. The real genius, though, is in how these layers are designed to talk to each other.
All right, this is where it gets good. Let's go back to our big order of computer mice. We're going to follow the data as it travels down this 5-level ladder and see exactly how ISA 95 takes that chaotic paper trail and turns it into a smart, visible process.
First things first, we get rid of the paper. We connect level 4, the ERP, directly to level 3. And this is where something called a manufacturing execution system, or MES, comes in. Instead of printing a ticket, the ERP just zaps the order details straight to the MES. And bam! Instantly, we have a digital record. We can see what's happening in real time.
This is already a huge step up, right? We can finally see the order in a system. But wait a minute. A system is only as good as the data you feed it. So where does the MES get its information? And how do we know it's actually accurate?
And this is where the lower levels just shine. The old way, you're relying on a worker to hopefully remember to scan a barcode after they finish a job. The timing is always going to be a little off, right? But with ISA 95, you use levels 0, 1, and 2 to get the data straight from the source. The machines themselves report exactly when they start and when they stop. No guesswork involved.
Okay, but here's where it gets really interesting and, frankly, super complicated. That level 1 stuff involves things called PLCs, basically the little brains inside each machine. The problem? There are more than 200 different kinds of them out there on the market. And guess what? They all speak their own unique language.
So this is why levels 1 and 2 are so absolutely critical. You can think of them as the United Nations of the factory floor. They're universal translators. They take all that noise, all those different signals from all those different machines, and they turn it into one clean, standardized language that the MES up at level 3 can actually understand.
So that brings up a really important question, right? Why go through all this trouble? Why have 5 separate layers? Why not just build one giant mega system that does everything from top to bottom?
Well, it all comes down to a really fundamental engineering principle. Each performs its own duties. Every layer has its own job to do. And maybe even more important, each layer operates at a totally different speed. Your ERP up top is thinking in terms of days, maybe weeks. The machine controllers at the bottom, they're thinking in milliseconds. And trying to mix those two is a recipe for disaster.
Because what happens when you try to build that one giant system, it becomes a monster. As soon as you try to grow or make a change, the whole thing gets tangled and chaotic. performance tanks, it starts crashing all the time, you start losing precious data, and eventually, nobody can even figure out how to maintain the thing anymore.
And that's why the ISA 95 layered approach exists. It's built for one thing above all else: stability. And let's be real, when your entire factory is running on software, stability isn't just some nice-to-have feature. It is everything. It is the bedrock of the entire operation. Okay, so this brings us to one last, kind of provocative question. The whole goal here is to build this perfect, super stable, paperless smart factory. But what happens when that perfect system fails?
Seriously, think about that for a second. Once you've gone fully paperless, your entire operation, every single thing you do, hinges on that system staying up. There are no paperwork orders to fall back on anymore. A single crash could bring your entire production line to a dead stop. And that really shows you why this ISA 95 blueprint isn't just some technical detail about efficiency. It is about building a tough, resilient foundation for the entire future of manufacturing.